Alright, for this next one we're going to show you how to rotate 3D about a side. A lot of you are doing something similar where it's rotating about a certain direction. So take your 4 points in your curves and we're going to work from there, and also keep your container of your geometry. And I will just build it up from here. So if you pull onto your canvas the rotate 3D, let's check out what that wants. It needs a geometry, it needs an angle, and it needs a center point for rotation, as well as the direction and a vector. So for our geometry, if you plug in the output of the singular collection of all of our curves into the G, you're going to see that it's automatically going to do a rotation in 3D about the origin, because that's the defaulted point. If you see this, the angle is defaulted at 0.5 times pi, and the center point is going to be at 0, 0, 0, 0, 0, 0. The direction is going to be in the z-axis, is indicated here is 0, 0.0, 0, 0.0, and 1.0, which is fine for the orientation of our component right now. However, I'll show you how to feed into a vector into this portion of the component. So what we're going to do first is bring in a number slider onto our canvas. You can do any kind of arrangement of any kind of integer input here if you'd like. I'm just going to do a slider from now to show you how to play with the movement. So what we need to do then is set this to be 360, because most of you guys were working with in degrees. And then we need to translate this into radians, because it's asking for rotation, angle, and radians. So what you type in onto your component, your canvas, is a degree component, and what this puts in, no, my apologies, is degree. I had it right the first time. No, that's still not right. Radians. You type in radians and it inputs the degree and outputs the radians for you. So plug that in there, and then now when we rotate this, it's going to be working off of the degrees in which you've been working with your component. So for the center point though, we want to get a point that'll be on our pyramid regardless of what's going on, because we're going to scale this after this step. So what you can use is called point on curve, and this will take apart any point on a curve that we have. So as we built, this is from an older exercise from this morning. If I were to highlight these so you could see them, the curves weren't as cleanly organized, and we had the edge curves, like these two are combined, and then this one was just one. So for now I'm just going to take this curve and say I want the point on the curve to be anywhere along these 2 points. It doesn't matter precisely where it is, so we'll just put that there, and you can see that the rotation is now going to be happening about that point. But now we need to set the axis and angle. So the way that we can do this also is, because we have the 2 points, is do a 2-point vector. Vector 2-point, and feed in the first and second points that make up that line. So if we preview this, I think not that and this curve, this point. Yes, so feed that into your A, feed that into your B, and then we have 2 points that are selected. The U talks about if it's a unitized vector or not. It's of another Boolean function. We don't need to be concerned for this for now. And then it's going to give us the output of a vector. So we can plug this into our X, and you can see that this vector correlates to that angle between these 2 points. So if we were to do rotation now, it would be about these 2 points within our form.